Hi everyone, I'm Angela, and today I'll be talking about our work on hierarchical neural story generation, which I did with Mike Lewis and Jan Dauphin. And we also have a poster later if you have anything you want to chat about. So the fundamental question that we work on in this paper is, what does it take to generate a story? So we show an example story from our data set here, and there are many challenges with story generation as a text generation task. So first, as you can see in this example, stories are very long. So if you contrast this with many text generation tasks such as translation, those are often done on the sentence-by-sentence basis, whereas here the model really needs to write a substantial amount of text, which exaggerates issues with generation such as repetitiveness and incoherency when you write multiple sentences. Second, there's a lot of complicated relationships and progressions between sentences in a story. The model has to do a lot of planning. So for example, in this story, the model needs to realize that because the character is walking on uneven terrain, she would need to lift herself up when she steps to the next part in her adventure. And lastly, there are two other issues, which is that story generation is very creative. So if you contrast this with generation tasks such as summarization, where a lot of information is contained in the source already, here the model really needs to one-shot write the entire story. And lastly, we don't really have great evaluation metrics for a good story, so we actually need to tackle this as well. So we structure story writing as a hierarchical task. So first, the models receive a premise that they're going to base a story off of. In our model, we have a language model that generates this premise, which we call a prompt. Now, this premise enables planning. So the model can then, given the premise, write the full story. And this allows a little bit more planning, because at each step of writing the story, it can always refer back to the prompt, which improves coherency. So to this end, we create a data set called writing prompts of 300,000 pairs of prompts and stories, which we collect from Reddit. And our data set is open source online, and you can use it to do this type of hierarchical story writing. And we also contribute a set of evaluation metrics, which I'll talk about later in this talk. On the modeling side, we make several improvements to multi-sentence generation, which I'll briefly discuss. The first is that we improve the model's ability to condition upon the text it has already written using self-attention. So in the paper, attention is all you can need, Vaswani et al. Promote this attention mechanism, which allows the model to keep track of stuff that it has already said. So in our paper, we add more capacity to the self-attention mechanism to allow the model to make really fine-grained and powerful decisions about what text it wants to focus on in the past. And we also reduce the amount of redundancy learned in the self-attention mechanism, which causes it to be a little bit more powerful. Second is that we improve the model's ability to actually condition upon the prompt. So one common problem with sequence-to-sequence models is that compared to the local dependencies learned in language modeling, such as should you write a period next, it's very difficult for models to learn the high-level structure of what it means to write a story or what is a plot. So that means that when we write our models with a sequence-to-sequence, even though we condition upon the prompt, it's easy for the model to kind of ignore that and just degrade into language modeling. So we improve this with a mechanism called model fusion. So in this model fusion approach, we first pre-train a sequence-to-sequence model on our data set, and it learns those local dependencies of language modeling. Then we provide that pre-trained model to a second model, which kind of like a residual connection, the second model tends to learn things that the first didn't pick up on, so it actually learns to condition upon the premise. So I'll show some example stories that we've generated here. So in the first one, the model is tasked with writing a story about aliens that have abducted humans. So it generates text like, the last of my kind is gone and there's a ship coming, and you hear a distant scream. And in the second one, we have scientists that have discovered something terrible. So the model is able to associate the word scientist with things like chemicals, viruses, and doctors. And the something terrible part, we've discovered some chemicals that may destroy planets or are monsters, and they're super dangerous. So the stories are pretty fun to look at. The last part I want to talk about is evaluation. So we evaluate in three ways. First is perplexity. So we show, compared to several baselines such as language modeling or sequence-to-sequence models, our fusion model is able to improve perplexity about 9 perplexity points, even if you compare to something strong like ensembling, where you have two models ensembled together. We also propose this evaluation metric of prompt pairing. So in our data set, we have the hypothesis that if the stories actually relate to the prompt, and then you show people the prompts and stories scrambled, they should be able to pair them back together, which would be a strong indication that the stories written actually relate to the prompt. So we ask people to do this pairing task, and we measure accuracy, and we show that our fusion model is significantly better than our baseline model, and can even match a very strong baseline, such as K nearest neighbors, where the model actually just finds a human written story, and it's not a generated story. Lastly, we ask humans directly like which stories they prefer, either the stories generated by our language model or the stories written in our hierarchical approach, and we find that humans strongly prefer our hierarchical model about 2-to-1. Thanks for listening, and we have our data, code, pre-trained models, and a great seek-to-seek library here at this link.